Question 5 on the practice test tells us that glucose, C6H12O6, is oxidized by molecular oxygen, O2, to form carbon dioxide and water. The question asks how many moles of oxygen are needed for 63 moles of glucose to be oxidized, and there's a little extra mole in there in terms of there's a typo. So express your answer to the nearest tenth. All right, so as always, we want to clearly identify where we're starting. So what I call the given, where we're starting, is the 63 moles of glucose. And what do we want? We want moles of oxygen. And once we identify where we're starting and where we're ending up, we can identify this as a stoichiometry problem. And stoichiometry problems always begin with one chemical, so in this case glucose, and always asks you to solve for a different chemical, in this case oxygen. And the relationship between these two can be found in the balanced chemical equation. So mole to mole stoichiometry is always the same. You multiply the moles of your given value by the mole ratio, and that is it. That's all you have to do. So the most complicated thing is figuring out the mole ratio, and that just takes practice. The mole ratio always has the same format. The given chemical is always in the denominator. So for us, moles of glucose is going to be in the denominator. And the chemical that we're trying to find out about always goes in the numerator. So we're trying to find out about oxygen, so moles of oxygen goes in the numerator. So the mole ratio has moles in the numerator and the denominator. The chemicals are different. The chemical in the denominator is the chemical you're starting with, and the chemical in the numerator is the chemical that you're solving for. And then these numbers I've bolded because you get those from the balanced chemical equation. So if we look back at our problem, we're given a balanced chemical equation which states every mole of glucose requires 6 moles of oxygen. So that's how we complete our mole ratio. Given chemical, denominator, desired chemical in the numerator, and coefficients from the balanced chemical equation. And then we take the mole ratio and multiply it by the moles of our given chemical, and that is it. And it's very useful to write out all of your units, so that way you can see, make sure that everything cancels out. Your units are your friends, and it is well worth the extra time it is required to write them out. So our given amount, 63 moles of glucose, we multiply it by our mole ratio, 6 moles of oxygen per 1 mole of glucose. Our moles of glucose cancel out, and we end up with 378 moles of oxygen. Now in this case, it's a whole number, so we don't have to include the tenth, but the question did ask for the tenth, so you would want to include that in your answer.